Hello, and welcome to this Tungsten Cluster masterclass training session where we take a deeper look at multi-cluster topologies. Specifically in this session we're looking at dynamic active-active. My name is Chris Parker, VP of Customer Success here at Continuant. So in this session we'll start by reviewing what the dynamic active-active topology is and how it works, and we'll discuss any additional considerations, review the configuration files to build a topology, and I'll finish with a demonstration of the topology being installed. So what is dynamic active-active? Dynamic active-active, or DAA, this builds on the foundation of the composite active-active topology, and the cluster continues to operate and be configured in the same way. The difference is, with dynamic active-active, the cluster instructs the proxy layer to behave like a composite active-passive cluster. So within your configuration, you specify write affinity to a single cluster, meaning that all reads will continue to balance between local replicas, but all writes will be directed to only one cluster. The benefit of dynamic active-active is being able to direct writes to only one cluster, avoids all the inherent risks of a true active-active deployment, such as conflicts when the same row is altered in both clusters. This is especially useful for deployments that do not have the ability to avoid conflicts programmatically. The additional benefit this topology offers is instant failover of writes in the event of a cluster failure. In dynamic active-active, if the cluster with write affinity fails, writes instantly fail over to the other cluster, and because that cluster is open for writes, applications will continue uninterrupted. This differs from a composite active-passive cluster, where in the event of a failure there needs to be a manual failover process to reroute write operations. So what are the configuration considerations? As with all of our clusters, the usual prerequisites that we covered in earlier sessions need to be in place. For more information on that, please do review our documentation. For network connectivity, not only do you need to ensure local cluster nodes can communicate, but you also need to ensure they can communicate across regions. This could have additional security considerations within your organization and should be handled accordingly. A full list of the network ports required are listed in our documentation. Like active-active, there are additional THL ports required. The default port for all clusters for the THL is 2112. With each cluster that gets added, the additional port would increment by 1. So for example, for 2 clusters you would need 2112 and 2113. For 3 clusters, 2112, 2113 and 2114, and so on. To ensure consistency in replication, it's also mandatory that your binary logging in MySQL is set to row-based logging. And you need to ensure the network latency between clusters is adequate to ensure timely replication. Whilst we do not have a documented minimum latency expectation, you should be aware of the implications of high latency. Finally, the connector behavior, which is what sets dynamic active-active apart from regular active-active. With dynamic active-active, you configure the affinity for the connectors, so defining the write affinity and the read affinity. All connectors should be configured with write affinity to the same cluster across the entire topology. Read affinity should be set for the local cluster that the connectors are associated with. Upon a failure of the cluster that has write affinity, the connectors will reroute to another cluster. When the original cluster is recovered, you can then choose to have the connectors reroute back to that original write affinity cluster or to remain where they are. And this will make more sense when I show you the config, which is our next section. So the configuration is basically the same as active-active. All the clusters are defined as active clusters. The key difference here is the affinity, and I've highlighted them in bold here to show you the differences. First, in the defaults, we have connector reset when affinity back equals true. That can either be true or false, and what that means is when, let's say for example, the alpha cluster fails, writes are rerouted to the beta cluster. When the alpha cluster is recovered, what do you want to happen? Do you want those writes to reroute back to alpha and honour the original affinity settings, or do you want them just to stay where they are? So if you want them to reroute back to the original settings, have this property set to true, otherwise set this to false. And then the other differences are within alpha and beta. You see within alpha we have connector write affinity equals alpha, connector read affinity equals alpha. That means the connectors within alpha will write and read from the alpha nodes. Within beta, the write affinity is also alpha, whereas the read affinity is beta. Therefore the writes will go to the alpha nodes, the reads will be balanced across the beta nodes. To look at this connector affinity in more detail, there are 2 ways you can specify it. How I've shown you on the previous slide with the write affinity and the read affinity, or you can have one single connector affinity line which defines all of those rules. So here we have an example, 2 sites, alpha and beta. So for all connectors, the write affinity would be alpha. the alpha connectors, the read affinity would be alpha. For beta connectors, the read affinity would be beta. In the simplified single line example, all the alpha connectors would have connector affinity of alpha, comma beta, and beta would be alpha, beta, beta. So this is basically saying in the alpha line that the first definition is the writes, so alpha for writes, alpha for reads, comma beta. Beta there is where do we go if we fail. Okay, so if alpha fails, we go to beta. So if you had multiple clusters, if you had 3 clusters here, so we had a third cluster called Charlie, this could be alpha, beta, Charlie. And then in the beta session, we have alpha for writes, because that's where we want the writes to go to. Beta is for reads, but also beta for the next failover. If alpha fails, beta becomes writes. So using the alpha, beta, Charlie example, the beta here could be alpha, beta, beta, Charlie, and Charlie could be alpha, beta, Charlie, Charlie. It sounds quite complicated, but it's very, very straightforward. It's writes, reads, writes, so the backup for those writes. If you find it easier, you can use the connector write affinity and the connector read affinity combined, or you can combine them like we see here. I'm now going to switch to my console session, and I'll show you how this looks in practice and how we actually set this up. Right, so I have 3 sessions here. I have DB 4, 5 and 6 as we see here, and in my other terminal session I have DBs 1, 2 and 3. So my configuration file I have set up using the write affinity, read affinity settings as we've looked at in the previous slide, and I've also got my reset when affinity back equals true. For this demonstration, I've also got my connectors in port-based routing, so I've set up a read-only port for 3307 and I've disabled bridge mode. This is just so that I can demonstrate the failover easier in the demo environment. So first of all, we're going to install the software. So tools, tpm install. And I will do that on 4, 5 and 6 as well. Tools, tpm install. And then we'll just wait for that installation to complete, which will just take a few moments. Okay, nodes 1, 2 and 3 are complete. And there we go, 4, 5 and 6 have just completed as well. Exit out of here, log back in to reload the environment. Same here, exit, log back in. And then the first thing I now need to do is configure my user map, because I'm not using bridge mode, I'm using port-based routing. So first of all, user.map, edit this file. I have a demo user I created, so I'm just going to use that one for the demonstration, which is demo user. And you can see here in the user map, those write affinity settings have been set up here. So alpha, alpha. So this is saying the write and read affinities for these particular connectors. And if I go to 4, 5 and 6, and I do the same change, and here you see it says alpha, beta. So alpha is getting the writes, beta is getting the reads. And there we go. Just an extra piece of information. If my connectors were already running and I changed the user map file, you don't need to restart the connectors. The connectors will detect a change to this file and will automatically reload it. I haven't actually started my software yet anyway, but I just wanted to point that out, as sometimes that does get asked by customers. They ask if they need to restart the connector after making a change to that file, and the answer is no, you don't. So let's start up the software. Wait for that, start the replicator, the manager. They were starting the connectors. Now typically, obviously my connectors in a production environment would be on dedicated hosts. Just for simplicity and for the purpose of the demonstration, I'm installing them all locally. So everything is running, so I'm just going to go into cctrl and let's just do a quick sanity check that the cluster is as we expect. So alpha, so we have all the nodes there, the primary node, the replica nodes. Let's go to beta. And we see all of the nodes there as well as we expect. And then if I go to the global composite level, I can see the composite services alpha beta along with their subsequent underlying cross-site services, the alpha from beta and the beta from alpha, which deal with that cross-site replication between the two clusters. Okay, so now I will show you how the connectors behave. So first of all, I'll look at DB3. So DB3 is a replica node, but I'm going to focus on the connector in this case. So MySQL -u demo user, my password, and I'm going to connect through the connector on DB2, and I'm going to connect to port 3306, which is my application port, so my write port. And if I look here, I'm connected to DB1, which is the primary node within the alpha cluster, which is great, that's what I want. So if I look at the read-only port, I'm connected to DB3, which is a replica, so that's my read-only host, that's my read-only port for doing queries. Great. Let's jump to the other cluster, to the beta cluster. I've got a window here on 5, so let's use this one. We'll use demo user, password of secret. My host, this time I'll connect through the connector on, let's go for DB6, and we'll do port 3306, which is our write port. Now in active, just plain active, this would connect me through to the primary node within the beta cluster, which would take me to DB4. But because we've set up those affinity rules and we only want to use one of the primary nodes for writes, it's actually connecting me through to DB1 in the alpha cluster, because that's where we have the write affinity set. If we look at the read affinity, look at the read-only port, we are now at DB6. Okay, so that's how the connectors are following that write affinity to go through to alpha. So what happens now if we were to simulate the loss of the alpha cluster? Well, first of all, to do this, I'm just going to go into cctrl at the global level, and I'm going to say data source alpha drain. So this can only be done at the composite level, the top level. This command is effectively going to shun this alpha cluster, so effectively take it out of service. Okay, it says it's shunned. If I look now, composite-master shunned, everything is good. Well, it's not good, but you know what I mean. It's for the purpose of the demonstration, it's good. So now I'm going to rerun those queries. So DB3, my connector is still running on DB3, and I'm going to say, right, I want to connect to primary node. I'm issuing a connection to the connector on DB2, port 3306, which is my write port. And I can see here I'm now actually connected to DB4, which is the primary node in the beta cluster. So we've failed over to that other cluster. No other actions needed to be taken. That failover was automatically handled by the connectors. And if I go to the read port, that is also over in the beta cluster, because we're seeing the alpha cluster as out of service. So my reads have also failed over to that beta cluster. If I go to the beta cluster, so where this connection previously connected me to DB1, it's now connecting me to DB4, and reads should be unchanged, and they will continue to work against my own local cluster. So there we go. What happens now when we recover? So let's go back into cctrl. I've set the property to reset back when recovery to true. So in theory, if I recover, use global, issue the recover command, this will just bring that alpha cluster back into service. So it will clear the shunned state. It will make sure replication is up to date, make sure everything is running okay. It will re-broadcast all of that information via the managers to the other nodes, to the connectors, and the connectors, because we have that reset when back affinity property set to true, our settings should revert to how they were prior to the failure. So my connection to 3306 from an alpha node takes me back to the alpha primary node, and similarly in the beta cluster, the 3306 has also reset me back to the alpha node. Okay, very simple, very straightforward. The cluster otherwise operates exactly like an active-active cluster, but it's the connectors that add that layer of intelligence so that you only use one of your primary nodes to handle the writes, avoids all of the risks and complications with potential conflicts, and helps you overcome those challenges. So in summary, we reviewed the dynamic active-active topology. We looked at the configuration considerations for it and how to set it up. We looked at the connector affinity rules, and then I demonstrated how that works with an installation, and then showed you how the affinity sticks to one cluster, fails when it needs to, and fails back depending upon the value of that setting for the affinity. So I hope you found this session useful, and I look forward to welcoming you on a future training session very soon. Thank you and goodbye.